Hey guys, we are here on a 2017 Chevy Trax. This is actually a follow-up of our blower motor resistor that we called as being bad. If you guys remember, we had melted pins on the blower resistor. We did all of our checks. I said, blower motor's fine, change the cabin air filter, bad connections, right? That was our call. We're back. It lasted a day. This is a new one. This down here is the new connector, the new connector, because it was done once already. And this one lasted one day. Pete called me and said, hey, I can't get the plug unplugged. I'm like, yeah, well, it melted again. And then I was asking him, well, did you change the cabin air filter? Was the connector right? Like I had concerns about the pins inside of this compared to the connector itself, right? One of my concerns from the get-go was poor connection. Anytime you have melted pins up in here, we had mentioned poor connection being typically the cause. The factory connector was not melted. The factory resistor that went bad was not melted. It only worked in one speed. The melting part didn't happen until the resistor was changed. I had concerns with an aftermarket resistor pins being a different size, maybe than the factory connector. Were the factory pins any different? I don't think they were, but you know, anytime you see pins melted, you worry about connector issues. This feels fine. Like that feels nice and tight. Oh, why is that lower? Oh, yeah, duh. I got the key on, I got this, you don't want to run these outside of airflow because of heat, okay? But I am on high. The heat comes from the lower speeds. Anyway, that was a mistake on my part. But this connector, it's melted in there. This was a factory replacement harness. This one is an aftermarket replacement harness. Really can't answer that question that we have without pulling this apart, and I can't pull it apart. So let's try to break it. Nice. Same pins. The third one over is the main ground. That's that guy. And that's the one that has most of the heat, the main ground wire. Those connectors look fine as far as my variable of them being the wrong ones. Not the case. So before I came here, I said, Pete, wire in a new connector. And you know what? Get a new blower motor. I didn't have specs for what the motor would draw. It's like, try to look up a fuel pump spec, current flow for a car. You're not gonna find it. Same way with a blower motor. I don't believe service information has it. It may, I could be wrong on that. 40 amp fuse, if you guys remember, this is on. And we peaked above 40 for, what did we say, 200 milliseconds very quickly. Electric motors, when they first start, have very high amperage until they start spinning. Totally normal. But what we're gonna do now before this motor gets installed, because it has to actually be cut, we're gonna do comparisons on high, full ground, through the power probe, both motors, and let's see what kind of amperage we have. One other piece that I just noticed when I got under here, I'm gonna use my phone here for the recording. I want you guys to see what I saw on the bottom of the blower motor. I don't know that this is necessarily an indication of a problem, but we got some rust-colored dust on the bottom of this motor. You see, I just wiped some of that off with my finger, and so that's gonna be a bushing or bearing. And the other variable is we never got first-hand information from the customer, which is, was this blower motor making noise? Did it change pitch at all while you're driving? You know, those kind of things where you can have a motor while we're testing it, which seems to be okay, but while they're driving it, not the case. And that's another possibility, but I didn't notice that dust before. I am now. But this is the big one here, guys. Stay with me. Old motor, new motor, amperage. Right now I have the factory motor still plugged in. I'm gonna use my power probe so we have the same ground. A variable with this tool would be, yeah, I am applying a full ground when I hit the switch downward, but it also has a thermal resistor or limiter in it, and that can reduce current flow. So if anything lower than normal current using this probe could happen, once it starts to go to its thermal break, but that's not going to cause too high of amperage. If anything lower than, so this is going to be our shot of our blower motor that still exists in the car. Okay. Cursor 1 showing a 39 amp peak. Initial surge, 39 amps, and then we're down around 16 amps in this area where cursor 2 is. And we'll zoom in a little bit more on that, just to get a good average. Yeah, it's 15 amps there, and the peaks of these are the armatures of the motor. 17, so between 15 and 17 amps of current. I just still am shocked that 16 amps, 17 amps would burn that up. It's on a 40 amp circuit. So the difference here, I can't bolt this in because you have to cut the housing to change this. And you know, there could be restriction in there as well. So there's not the same playing field, if you want to call it. This motor being out in the open, that one being up in the dash, that's a variable. Let's see what we have on this one. So what do we see right off the bat? We have less initial amperage. That initial amperage part really shouldn't be a factor of where it lives, whether out here or inside of the dash. So that part we can definitely rely on. I think we can anyway, but just talking about variables here. Cursor 1 is showing 32 amps as opposed to 39 amps on the initial. And when we did it in the edits, I saw there was over 40, wasn't there? But it was very quick. It was very quick. And then what do we see here around cursor 2? Yeah, we're talking 10 amps of current. So we're 5 to 7 amps less while it's running too. Should have put a blower in this in the first place. I just really felt like those numbers were okay. Valley, this is cursor 1, is 9 amps. Peak is 10 amps. 15 to 17, old motor. 9 to 10, new motor. Peaks at 30, what did we say, 32? What was our amperage peak? Cursor 1, amperage peak, 32 amps, as opposed to 39. So Pete, even seeing these numbers, I would have said to not worry about the blower motor probably again. Right. I do see a dust on the bottom of the blower. Yeah. It was like dusty.
Cover. There's see that cover.
Oh, that's why I didn't see it.
Yep.
That gives me a better shot of it.
Yeah,
I did not realize that there was a cover.
That's why you never saw it.
That's why I never saw it. So that's the stuff we're talking about. This kind of brownish, blackish. That's bearing material. And what we don't know, again, was this motor at times making noise for this customer? Yeah. We don't know that. We don't know if when they're driving it, if it changed pitch, if the airflow slowed down, all of those things, that our numbers could be even higher than what we're showing here. But I'm comfortable, Pete, with the new motor. I think we're gonna be okay. It is the ground pin. I did get this apart. It was the ground pin that got burnt. The one that comes from the motor is the third pin in, and then the external ground is the one next to it. But the one coming from the motor is the one that got burnt.
So that's the motor.
That's the one that carries the most current. Right. So it isn't like one of the resistors got hot. It was actually the ground wire of the motor itself. I'm sorry, Pete.
Oh no.
That was a mistake on my part.
Well, like you said, the cover wasn't off, so
and these amperage numbers even after, right, they're only, so I'm 32 and 39, so we're 7 off on the initial spike. So
like you said, one of it spikes up to 50 or 60 when it's higher when it's
I think more so than the spike would be the nominal current. This spike on the other one spiked off the screen, and then the average down here, we're at 10 amps. Mm-hmm. We're at like 15 to 17 amps on the other ones. We're talking, almost 7 amps of current difference between the two. I wouldn't think that would melt that. The fan sounded fine. The airflow sounded fine. I didn't hear any noises. The rule that we've always followed when you have something like that is you probably change the blower anyway, just as a precaution. probably is a good idea to still follow.
For the
For these, you get a burnt blower
I've changed a lot of
resistor.
them without changing.
I
it,
know, yeah.
But if it's burnt in that third wire, the ground, it's probably a motor.
I mean, if it's burnt on the blower motor ground wire itself,
That's usually where they're all burnt.
And I don't know that we can really even use that either, Pete. But I guess it wasn't like I was trying to save the customer money. I just didn't want to spend their money needlessly.
Right.
I really felt like this wasn't needed, and that was a mistake on my part. It's like these specs aren't given to you.
Right.
You can't look up blower motor amperage.
Right.
Not in service info that I've ever seen. I should probably try before we give up here. But yeah, we're on average 7 amps lower with this.
Okay.
So I say put the motor in.
All right.
Okay.
Cut it out now.
Yeah. I just don't know if I've ever seen, try looking up a cooling fan electric motor amperage, a fuel pump electric motor amperage. I just don't know that it's there because it's very subjective too. OEM testing of the blower motor. Relay controlled by the BCM, resistors, got all that. When blower switches in the high position, ground is applied directly to the blower motor through the blower switch. Right, but it does come down through the resistor regardless. Circuit testing. So it doesn't open the list up. I got using connector test adapters, probing electrical connections. I'm not reading all these. See if they give me some kind of amperage. Showing a 20 amp fuse jumper wire, it says, which may not be suitable for some circuits, so that's generic. Measuring voltage, voltage drop, frequency, testing ground and low ref circuits, short to ground, short to voltage. This is all generic stuff here. I'm not seeing anything in here for amperage, which I didn't think so. Of course, they're having measure. Wait. It's giving me specs for my digital multimeter. Come on. There's nothing here. My circuit testing with a digital multimeter is literally giving me a description of the specs that they want for the multimeter. Okay, I'm done looking for this because it's frustrating. If you guys got a spec for me, I'd love it. Good luck to you if you don't. When you run into one of these, there were variables to this, which was the connector wasn't melted from the get-go. It only worked on high speed, I think. And then the follow-up, which was done before we came down, which was like, hey, put a new resistor in, it's not working. It was burnt. It wasn't burnt until it was replaced. And that just very well may be just inferior parts. Because each one of these blower resistors has been aftermarket. That very well may be, because all of the current's got to pass through that. What's the short answer for this? You get a blower motor that's melted like that, resistor that's melted like that, you have to consider too much amperage from the motor itself. And this is one, I wish I had a definitive one. I showed you the readings. I still would be, right now, I would still be questioning, is that blower motor bad? With the dust and now with the amperage readings, I can say, yeah, that's probably the case here. But before that, with the cover on, can't see any dust, and amperage to me seemingly okay. Like 15 amps of current still does not raise any red flags to me. But it's now 10, and it's 32 instead of 39. Yeah. So, hope you learned something. Tread carefully would be the answer. I still don't want to say if you have a melted resistor, change the motor automatically, because I have done hundreds of these where it was just poor connections at the resistor, bad resistor, and the motor's fine. So, was not the case in this one. Yeah, just I guess the final takeaway is make sure you're communicating with your customers. That's going to be key. So, thanks guys for joining us. We'll see you next time. All right, so some final follow-up thoughts on this Chevy Trax with the blower. And this is really going to be highly revolving around comments. And then one other piece in the video that maybe you guys missed. But let's read some of the comments. This guy says, another parts store blower resistor meltdown. Maybe one day people will stop using Chinese parts store parts. This guy says, genuine only with those. Had a tight ass customer who made me put 3 aftermarket connectors and resistors in before he would listen to me. Didn't bother me as I get paid every time. So 3 different ones melted down on him before he put a factory one in that fixed it. I've had this exact same problem with the same vehicle, went through multiple connectors and resistors. The fix was using a factory resistor. This guy says aftermarket parts, best to use one from You Pull It, a real OEM. This guy says, I've had this exact problem before on a Holden Trax over here in Australia. I replaced the resistor and plug and it did the same thing again. I put a new genuine resistor in with new connector and all is good. All right, and there's a few more too. So I'm bringing that to everyone's attention because I really feel like that probably would have fixed it too. I know we had some dust on the cover. You know, that can be, it was like a brownish color. I assumed that was from a brass bushing inside. I don't know. Could have been brushed material too. Could have been totally normal. I mean, the motor sounded fine. It's been fine since we put the blower motor in, and everything's aftermarket now. Everything's fine, but I just wonder if putting a factory resistor in there was the fix, because remember, it wasn't melted down at all until that aftermarket piece was put in. It didn't work in the other positions. It only worked in blower 4 originally. Oh, by the way, he was complaining about low heat. He was just low on coolant. So he's got a leak somewhere that's got to be addressed. But it worked on position 4 until Pete put the resistor in, then it melted down, and then, you know, a day later it melted down again. And then we put the blower in at that point. But so I think there's really good evidence, especially with a 16, 17 amp average, that blower would have been fine with a factory part. So that's one. The second one is my power probe was not fully grounding that circuit. I wonder how many of you guys saw that. You can see in this image, I'm grounding it with the power probe and the amp clamp is on there, and you see my average amperage up and the green trace up above is around 17 amps of current. But do you notice when I'm grounding this, I'm showing 2.16 volts on the end of that power probe. And I didn't pay attention to that. What that means, guys, is I was never fully grounding this in all of my measurements, in both the before and after. And yes, I know we had about a 7 amp difference before and after, right? Wasn't it about that, Caleb?
Yeah, about.
Maybe a little bit less, maybe 5 amps on the average, but about 7 amps on the peak. Mm-hmm. But with the power probe, what that's doing, the tool has a thermal limiter in it, and it's actually adding some resistance on the ground to protect itself from the high current flow. That's what you're looking at. And if I would have grounded it with a jumper wire, I would have needed a heavy jumper wire. But if I would have grounded it with a jumper wire, it would have grounded more, and our amperage was going to be even higher in all of my measurements, both the good one and the bad one. So I just wanted to bring that to everyone's attention too. All the numbers are going to be higher than what we measured. How much higher, I'm not sure. But those two things needed to be brought to attention to everyone that's dealing with something like this. Really, what should have been done from the get-go is a factory resistor. And there's multiple people from across the world who are confirming that same problem on the same model car. Is it safe to say over time the blower motor has deteriorated, the amperage has risen? Yes. Does it need a blower motor in that case? Maybe. But I think the key is the aftermarket part was probably built with the specs of what they anticipate the motor to draw when it's new, not when it's aged. And the aftermarket part just can't handle it. And you saw where it melted. It melted right at the contacts, not down in the resistor, but the contacts themselves. And that tells me poor, probably material that they're using for the contacts cannot handle the amperage that blower motor would produce as it has aged. That's what we got. We know we have a drop in amperage with the new motor. So it's still up for debate. Did it need the motor? You know, to each his own on that. I think when you run into one of these, you know, do your amperage checks like we did and go with a factory resistor, or change everything. Blower, resistor, harness. As long as the harness isn't melted, you don't need to change the harness, but change the blower, change the resistor together if you're going aftermarket. If you're going factory on this, you probably could get away with the resistor. Look forward to hearing your comments, guys. We appreciate you guys being with us, and we apologize for the missed call, if we want to call it that. I don't apologize for that. That's the way it goes. It's good to show it. I mean, there's no reason to hide when stuff like this happens. This is reality. This is what we do on this channel. We don't hide anything from you. We film live, and you know, we let the chips fall where they may. Is that the right phrase?
Sure.
All right, guys. Thanks so much for being with us. We'll see you next time.